Tonight, we're going to talk about related rate problems in introductory calculus. You know, a related rate problem is similar to the optimization problems that you probably did just before this, except now we're going to add in a third variable. And since we used the word rate, I think you can guess that that third variable will be time. What I want to do tonight is look at a problem and then try to come up with a generalized set of steps to solve these related problems. Let's try one. What's going to happen in a related rate problem is there's going to be action. There's going to be a ladder sliding down a wall, some sand pouring out, making a pile, a balloon rising, a boat moving. And all of those things have in common, that's right, time, a rate. So these are related rates. And so the key issue is going to be, how do we deal with time in our problems? Let's try one. Let's take a ladder. What we're going to do is we're going to have a wall and a floor. And let's have a 16-foot ladder leaning up against the wall. Let's say that the ladder starts at 5 feet away. We're going to pull the bottom out at 3 feet per second. Feet per second. That's a rate. What did you learn is another word for rate. That's right, derivative. If I tell you that the bottom is moving out at 3 feet per second, we're going to say that dx dt is 3 feet per second, and our ladder is moving out. We have a height, y. What happens as the bottom moves out? The top comes down. This is also a rate. And the question is going to be, find the height of the ladder when t equals 1. And then find the rate at which the ladder is falling when t equals 1. That's another rate. dy dt when t equals 1. Now the great thing about these related rate problems is that regardless of the context or the story, you solve them all the same way. That's right. So here we go. I have a situation here. Ladder's coming down, bottom's going out. As the ladder falls, what we're going to do is stop and then analyze what's going on. Let's see how it works. First thing I do is come up with an equation. The 5, I'm going to call this side x. So I'm going to say x squared plus y squared equals 16 squared. That formula, as will most of the formulas we use, comes from geometry. No calculus yet. Okay. Now, we've set up our situation. I've got a picture, I understand the problem, I've got an equation. Now, let's differentiate. With respect to t. Oh, this looks a lot like another thing that we did before, which is implicit differentiation. And that's exactly right. So all this is implicit differentiation, but instead of being with respect to x, we're doing it with respect to t. Always time. After all, these are related rates. Okay, we've differentiated, now we substitute. Perhaps the most important thing to remember with related rates is to differentiate, then substitute. But more on that in our next conversation. Let's go ahead and substitute in. Well, the ladder started at 5, and we want to find dy dt when t equals 1. If dx dt is moving out at 3 feet per second, and we start at 5, where will the bottom be when t equals 1? That's right, 8. 2 times 8 times 3. How about here? If the bottom's at 8, where is y? Now remember, the ladder was sliding down and we froze the action. Well, this is a right triangle. Hypotenuse 16, base 8. What's the height? Y squared plus 8 squared is 16 squared. We evaluate that, and we get our height to be root 192, which is 64 times 3. So 2 times 8 root 3. Now dy dt, that's what I want to find. And there's my equation. Hand this over to a random student from Algebra 2, and we get a solution. Our solution here ends up, should be, looks like the 2 in the 8, the 2 in the 8, 3 in the root 3, dy dt is negative 3 over root 3. Now, does that make sense? Let's see. The ladder is sliding down, so that rate should be negative. The bottom is going out, that rate should be positive. And sure enough, that's how this works. Our final step is to, of course, answer the question. dy dt, that's what I found here. My units, although I didn't include them here, you would read the problem to find the units were feet per second. And now you have your solution. This simple ladder problem illustrates everything you need to know about how to solve related rate problems. Let's take a look at the steps. 1. Understand the problem. Or, as we say in the math office, get a clue. Understand what's going on. Ladder sliding down. 2. Let's draw a picture and label it. We label what we're given, and most important, we label what we need to know. 3. Come up with an equation. It's usually going to come from geometry, but an equation that relates the variables and uses what we've given and uses what we need to know. 4. Differentiate. 5. Substitute. And remember, like I said earlier, these 2 steps are the most important. Differentiate before you substitute. But more on that later. Finally, answer the question. When you do this, whether it's with our simple ladder sliding down the wall problem or one that gets a little more complicated, your answer will be correct. And this is your method that we'll use every time. Thank you, and have a great evening.